All right. So we're going to be talking about Turtle this week. So Turtle it does involve coding, but it is, it creates visuals in Python, and you can draw with it and create an animation. So I think this week is going to be pretty fun. It's going to be a little different because it's not just pure coding. And so let's get started. Like I said, Turtle is a way to create visuals on a virtual canvas using code. And we can make it as simple as we want, or we can make it as complicated as we want. So, for example, it can be a simple flower, or it can be this really complex, really cool looking thing on the right. And we're going to learn all of the commands and how to make all of these today. So when we want to use Turtle, we must import Turtle at the very top of our code. So if you guys remember, if you recall, when we learned about using a random number generator, we have to import random for using random. When you're using Turtle, when you're drawing with Turtle, you always have to import Turtle. If you don't import Turtle, your program will throw an error, it will crash. So you have to do this at the very top of your code. Okay, so now let's open a REPL together that we're going to be using today. So we don't have to use Python with Turtle. It's optional. There's not really a big difference. So let's look up Replit. And once we log in, let's create our REPL. And I know that I wrote Python with Turtle on the slides, but just normal Python is the same thing. So you get the same result either way. Let's give your REPL a title. Let's call it whatever you want. Let's call it Turtle Week 5. So now that we have our REPL open, the first thing that we want to do whenever we want to use Turtle is import Turtle. So we're just going to write that at the top. And for now, we're going to leave it as is. We'll come back to it. So now hopping back to the slides, now that we have our new REPL made, let's learn more about Turtle. So whenever we want to start with Turtle to draw something, we have to declare a variable that we're going to draw with. So let's say we call our variable t. So t equals turtle.turtle with parentheses. So this turtle.turtle with parentheses, that is what you always have to type. That cannot be changed, and that is just how it is. This is the way we are going to initialize our Turtle drawings, and we're going to use the variable t to move this sort of mouse around to draw. So let's go back to our REPL and let's add turtle.turtle. So on our REPL, we can call this whatever variable we want, right? We can call it like turtle equals this, or just to make it simple, let's call it t. T equals turtle.turtle. Notice how this second turtle has to be capitalized and there has to be parentheses at the end. So this is just another, you must do this before you work anything with Turtle. So now we have these two lines of code, Let's run our program just to see what happens. We haven't told the computer to do anything with t yet, but let's just take a look. Okay, so it looks like on the right, instead of just one screen, we have two screens. We have our normal console on the bottom and some new screen at the top. Right now it is black, but soon it will turn into a white screen and we'll learn more about how to change stuff on there. So these are must-haves when you start coding with Turtle. Okay, so let's think about this code. Import turtle t equals turtle.turtle, and we have a for loop. We have for C in this list, red, green, blue, and yellow, t dot color equals C, t dot forward equals 75, and t dot left equals t dot left 90. So we have not learned these commands over here, but if you think about the names of them, it might be a little straightforward, right? So for every variable in the list, it's going to go through red, green, blue, and yellow. And for each of them, we are going to color C. So if you sort of think about it, even though we don't know it now, we can guess that it changes the color to red or green and blue and yellow. And then we move forward 75 and we turn left 90. So this is the output. So this is just a something to warm us up and get us thinking about it. So here are some logistical things that might help you visualize this, what we're doing. The screen is like a Canva and the turtle is sort of like a pen or a mouse. And we can change certain characteristics like size, color, and speed. And this pen, mouse, turtle, it will always point in a specific direction and it will move in that direction unless you tell it otherwise. So unless you change the direction of the mouse, it is going to move in a direction. So I'm going to refer to it as a mouse or a turtle or a pen, but essentially they're all the same thing, right? They help guide where your line is going or your drawing. So there are 4 directions when we work with Turtle. We can move forward or backward and also left and right. Left and right are more like which way we turn. Once we turn left or right, we can use forward and backwards to move. Okay, so more in detail, dot forward with parentheses and dot backwards is the direction that we're going to move in. And to change the direction of our mouse, we are going to use dot left parentheses or dot right parentheses. Inside the parentheses, we're going to put the number of degrees we want it to turn. So we can do dot left 90 or dot left 180, right? As long as it is a degree. So let's think about this code in green. Import turtle, t equals turtle dot turtle, and our first step, we have t dot right 90, t dot forward 100, t dot left 90, and t dot backward 100. So let's take a minute to think about this, and then we'll talk about our result, and we can use Replit to verify that we have guessed the correct output. So let's think. We have the variable t. So the first step, right, we tell it to turn right 90. So note that the mouse is going to be automatically facing the right. So from here, if we want to, our first step is to turn right 90 degrees. One way to think about it is if you are the mouse and you're going to turn right, my right is this way. So turn right 90 degrees. I'm going to be sort of angled a different way, right? It helps to use your body to visualize it. So we have turned right 90 degrees. So this is the new direction that it is facing. Next, we are told that the turtle is going to move forward 100. We can call it 100 steps. So we're going to move forward 100. We're facing the downward direction because we have turned right 90. Next, we have to turn left by 90 degrees. So that is this way. It is now facing this direction, the right direction of the slides. And then we want to move backwards by 100. So instead of moving forward, we're going to move backwards by 100. So this is the result. Okay, so now let's copy and paste this code in green that we just talked about. And let's copy that into our REPL. Let's see if my diagram is correct. So we basically have import turtle, the turtle.turtle, and our 4 commands. If we run our program, okay. If your code is also looking like mine, if you look at my screen, you can see a white box pop out, and then once it's done, it disappears. So if you're running into that issue, let's see. Okay, so if you're running into the issue where your screen collapses right after it is finished drawing, then I want you to write turtle.done with parentheses at the very end of your code. So this will prevent the screen from disappearing. If you don't have that issue, then that's great. But if you do, turtle.done fixes it. So now if we look, it looks like we guessed correct. That is how it looks. And notice how this is our screen here that pops up. And all of our drawings will be inside this top box, this top canvas. Pretty neat, I'd say. All right. So here's a little animation that also shows you the same thing. It's the same result that we had on REPL. It's important to understand the logic of how you're turning left or right, because when you want to draw other shapes, it is helpful to be able to visualize it in your head. So here are some shortened commands. So instead of writing like right, forward, left, or backward, we can use these shortened versions. Both of them do the exact same thing. Personally, I like to write it out using without shortening it, because writing it out helps me see it and understand which direction I'm moving. But same thing. Using these 4 commands, we can draw any shape that we want. It can be as basic as a triangle or a square, or we can make something like an octagon or something with 20 sides, as long as we know the angle that we want to turn and how much we want to move. Okay, so now let us think about how to draw a square. So we are going to use the 4 commands that we just learned, and using these 4, we can draw a square. So how can we do that? Okay, so let's think for a minute and let's try to write it out on our REPL. Let's try to code it out and see if we can draw a square. What do you think my first step should be in drawing a square? So, yeah, Pingshan.
So you should make all the you should first find a side length to use.
Yeah, great. I agree with you 100%. So, let's T dot, if we want to use a side length, we have to, that means we're going to move forward first, right? So we're going to move forward. Let's do 100. Let's see how big that is. And with a square, all the side lengths are the same. So after T dot forward, we want to turn, right? So we are going to turn, we can turn right by 90 degrees. After we turn right, do we want to move forward or backward? I think we should move forward, right? And it should also be hundreds and square. And I think that it makes sense if we just repeat these, right? So we're going to turn right again, and then we're going to move forward. And I think we need one more. Right. So let's run our program and see if we get a square or not. We do. Look at that. It's a nice square. And we only used forward and right. So hopefully you guys got that down in your REPL. I also have the code on the next slide. So if you want to copy and paste it, it's right there for you. And this video is like, if you want to open it on your own, it's, oh, there it is. It's the square. Okay, so now let's talk about the coordinate plane. I think many of you might have learned this in math already, but it is in Python and in Turtle, it is the Turtle screen is divided into 4 quadrants, so 4 equal parts. Our Turtle mouse is always going to start in the middle at 0, 0, and this is referred to as the home. So the home is 0, 0. That's where the turtle is going to start. So obviously the turtle goes to any other spot, but its home is always 0, 0. And if we want to move our turtle to any other coordinates, we can use dot go to with parentheses. My REPL still goes black even if I have T dot done. I think try turtle dot done, Jacob. I think we want to use turtle, not T. So turtle dot done, I think, should do the job. So back to go to, we have T dot go to x comma y. X comma y are the coordinates that we want the turtle to go to. So if we want the turtle to go to 100 comma 100, this is what we have to write. And then if we want to return the turtle to its home, we can do T dot home with parentheses. Notice that inside the parentheses for home, there's nothing inside of it. There's no 0, 0, it's just T dot home. And all right. So now let's try this out in our REPL. Let us go to our REPL and let's let's have our turtle go to some coordinate. T dot go to, and inside go to, we have to have our coordinates. Let's do negative 150, comma 10. And then the turtle is going to go home. T dot home. Okay. Let's see. So, whoa. Looks like we first have the square, and then it goes to negative 150, comma 10, and it goes back home. Okay, so now it looks like that works. Now let's talk about drawing preset figures. A preset figure is a figure that the turtle already knows how to draw. So, for example, a circle is a preset figure. We can write t dot circle 60. The number inside the parentheses is the radius of the circle. So the radius is the distance from the center of the circle to any other point on the circle. It's okay if you don't understand what a radius is, but basically it is if you increase the number inside the parentheses, then the circle is going to be larger. So 60, if 60 is the radius, and right, a circle of a radius of 60 is smaller than a circle with a radius of 100, for example. So now let's another preset figure is a dot. So a dot is like a filled in circle. It's just t dot dot 20. So 20 is the radius of the dot. And something more interesting, in my opinion, is changing the background color. So usually by default, the turtle screen has a white background, but we can change it to any other color that we want using turtle.bg color, and in quotation marks, the color that you want. So this is how it is going to be used. Something to note is that this turtle.bg color, it is always going to be turtle. It is never going to be the name of your turtle. So, right, if I have in this code right here, I have t equals turtle.turtle. And then when we want to change the background color, we have to use turtle.bg color. That would be correct. What would be incorrect would be t.bg color. That would not work. It is always turtle. So I think this is similar to the error that that Jacob had with t.done, right? It's not going to be your variable .done, it's going to be turtle.done. So similar to this, it has to be turtle.bg color. If it's your variable name, like t.bg color, that is wrong. So pretty. So here are some of the colors that we can use for TurtlePython. We can use any of these names inside this background color. So here's the link for access, and as long as the spelling and the capitalization is all the same, then we can use any of these colors for our background. So let us go to our REPL and let's change the background for our canvas. So I like to put the background color first, so the background will change right away. So we have to do turtle.bg color, parentheses. Inside the parentheses, we have quotation marks and whatever color we want. So I'm going to go to the website, the Wikipedia website, and I'm going to choose a color. You guys can do the same right now. There's a lot of different options. I'm going to go with I'm going to see how Peach Puff looks like. That's pretty. I think I'm going to go with Peach Puff. So now that we have our background change, now our turtle looks pretty. And another customization thing, coming back to the slides, we can change the screen title. So we can customize it and make it more personal using turtle.title with your title name. So now let's go back to our REPL and let's also change the title of our REPL, of our turtle Canva. So I'm going to change it right after the background color. So for me, I'm going to do turtle.title and the title that I want. So let's call this, let's make it interesting. Let's call it Claire's Fancy Drawing. So now let's run our REPL and see. Right now at the top, it says Claire's Fancy Drawing. So that is that. Notice how this is also turtle.title, right? It has to be turtle.title. It's not going to be your variable. It's not going to be like t.title. It's always turtle.title. Great. So now that we have our background color done and our new title done, we're going to take a look at how we can change the size of our mouse. So if we want to just increase or decrease the size of our mouse or cursor, we're going to do t.shape size and the number that we want. So in the example, I have t.shape size 10 and t.forward 100. So notice how the mouse got enlarged 10 times. So the mouse is really, really huge. But when we move forward by 100, the line is still thin. So t.shape size only changes the size of the mouse. It does not change the size of the line that is drawn. Now changing the pen size is a little bit different, but pretty much the same. T.pen size, it changes the size of the mouse and also changes the size of the line that you draw. So everything will be the new size. So notice how in t.shape size, only the mouse is really big, but in t.pen size, everything is the same thickness. So this can be helpful when you're drawing. If you're drawing a picture in Turtle and you want to have like different borders or outlines. So now, what if I ask you, how can I change the color of the pen or the mouse that we draw, like the line that we draw? We can do this by using t.pen color and t.fill color. So t.pen color changes the color of the border of the mouse and the line that it makes. While t.fill color, it only changes the color inside of the mouse. So if you look at the code below, we have t.pen color equals green and t.fill color is red. So the line is green, but the color inside the mouse is red. Something for convenience and for efficiency, you can combine the two and you can write t.color, green, red. So the pen color comes first, then the fill color. So the pen color is green, so We get the same result as before, but this just takes less time and less code. All right, so now let's learn about filling an image. So personally, I like learning about topics in Turtle that involve color because then I get to choose my own color. So this should be fun. To add color to a drawing, we will use T.fill color, light pink. And then we have begin fill and end fill. So essentially what this is doing, I'm telling the program that I'm going to fill my turtle with the color light pink. And then I'm going to begin filling now. After I have begun filling, I'm going to draw my shape. Right? I'm going to go forward, I'm going to turn left, go forward, turn left, etc. And then I'm going to tell the program, end filling now. So in the time that we're drawing the shape, drawing the picture, we are filling the picture with light pink. So the color that we declare here, light pink, is the color that we're going to use to fill. Let's copy and paste this code into our REPL. Copy, paste. I'm going to delete the square that I drew previously, or you can leave it. So fill color is light pink, and begin fill, do this, do that, and end fill. Let's run our program and see what we get. Oh, oops, it says invalid character. I think we just have to change the quotation marks because the quotation marks in Google Slides is different from the quotation marks in REPL. So there we go. Now we have a triangle that is filled with pink. So we can change it to any other color we want. So if we want to do coral, I think coral is a color. You can do the same thing, but now it is a different color. So that is pretty useful when you're making things in Turtle because obviously it has to be colorful. Now to change the mouse shape, right now, if you go back to REPL, notice how the mouse is a triangle or like an arrow. We can change it to any shape that it allows. So we can change it to a turtle, we can change it to an arrow or a circle, a square. Here's some other options. So let's go to our REPL and let us change the shape of the mouse. I think that we should change the shape of the mouse before we start drawing the triangle so we can actually see if it works with the triangle. So T.shape, what shape should we do? Let's do a turtle. I think that's cute. So now let's run our program. Ooh, so we have a turtle instead of the boring triangle. So to change the speed of the pen, we can use T.speed and the speed that you want. Now we're going to learn about pen up and pen down. I think this is rather important if you're going to take something away from what we learned. So pen up and pen down. Pen up means like as if you were if you had like a physical pen and paper, I'm going to put my pen down, like I'm going to put my pen down and I'm going to draw something. And then pen up, I'm going to remove my pen from the surface of the paper. And then I'll move my pen somewhere else and then I'll draw again. So let's copy and paste this code into our REPL and see what this does. So I've copied the code from the slides into my REPL, and we have our triangle from before, and now we have a line with another line, a parallel line. But notice how there's no line connecting them? This is because we have lifted our pen, we have said pen up, and we have gone to another place. So let's go through the code and see how this works. So first we are moving forward by 100, we're turning right by 90 degrees, and then we have pen up. So we're lifting our pen up, and we're going to, with our pen lifted up, so we're not drawing anything since our pen is up, and we're going to move forward 100 and turn right 90. So we have gone to a new position without actually drawing anything on the screen. And then we have pen down, and we're going to draw something. And then when we have our pen down, then we're actually going to see visuals on the screen. Great. Clearing the screen, if you want to remove everything off the screen, we can do t.clear, parentheses. I'm just going to copy and paste that into my REPL and see what happens. It's like we're drawing, and now it's gone. So t.clear removes all your drawings from your screen. So now we can use for loops with a turtle. It's just a way to shorten your code. We can also use while loops. So here's something that you can try and copy and paste and test it on your own time. We're going to move on for now, but this is a really cool result. If you want to test it out right now or after class. You can also use input statements and if statements with Turtle. So here is the website that for all the things that we learned today. It's like a cheat sheet, if you will. You can control F something, right, if you forget. Obviously, you don't have to memorize everything, all the commands that we just talked about, but it is helpful to know them, right? So you don't have to go on Google and Google everything all the time. But so they are important to know. So now let's make a game. This is the part I'm excited about. So far we've been working on projects for homework. Like we've been working on rock, paper, scissors and the guessing game. And now let's make one using Turtle. So it's obviously going to be more interactive, more fun since we have visuals on the screen. So now let's open a new REPL that is different from the one that we were just working on. So let's make a new REPL, and the template can just be Python, and let's call it Turtle Project. We have our new REPL with any title that you want. And the project that we're going to be doing now is based off of the project at the end of this website. But what we're going to be doing is going to be a little more fancier than what they have. And just for reference, here is the finished project right here on slide 42. So for reference at the after class, we can look at that. Okay, so now let's start our project. I'm going to show you our final result. So here's the finished project. I'm going to show you just to see what we're going to create at the end. All right. But we're going to work to create this. Okay, what would you like to be called? Let's be called Claire. Let's be a green turtle. What is 9 times 3? 27. Press enter to roll the die. So essentially this is sort of a racing game, if you will, that involves questions that you ask the user, and it is based on luck, right? So you are the green turtle, and I get to customize the color of myself, the color of my turtle. And now it looks like I won. I beat the other turtle. So that is going to be what we're going to work on for the last 20 minutes. But we're going to go through it step by step together. So don't worry. So first, when we want to run turtle, what do we have to do first? What is our first thing that we have to write? We have to import turtle. And import turtle is our first line of code. And next we are going to import random, because I know that we're going to be having a random number somewhere in our project. So let's import random as well. All right. So after this, let's give the user some, what should we do first? We should change the color of the background, right? So right when the user comes into our project, they can see a pretty canvas with a color that is not white. So BG color, I'm going to do light blue for the ocean. You could do blue or any other shade of blue and now let's also change the title of our program. Let's call it turtle training, or you can call it turtle racing, whatever. 101. So now we have a changed background and a new title. So now let's give the user some instructions just to tell them what we're going to be doing. So let's say, hello there, you can write whatever you want for the instructions as long as they're like about the same thing as this. Hello there, you are about to embark on a turtle adventure. You are going to race against another turtle friend to see who reaches the finish line first.
Can you like say like the name of like who you're racing with?
Sure, if you want to. Who do you think we should be racing against?
Bob?
Bob. Bob. On your way to beat Bob, you will be answering some math questions. And just for the aesthetics, let's create a blank space. So this just enters like a new line, it skips a line. And let's ask the user for their name. So for this player one name equals input, what would you like to be called? So remember, we have to use an input statement to ask the user for their name. And one second. So let's print another blank space, like a blank line. And let's do print welcome to the race, player one name. So it's just gonna say, hey, welcome to the race, whatever your name is. So next we can now we're going to ask the user what they would like to be, what color they would like to be. Sounds weird to say, but what color turtle they would like to be. Input, what color turtle would you like to be? Let's give the user some choices so they know what they're choosing. You can make the colors whatever you want, right? They can be basic like red, green, orange, yellow, but just to make it prettier, let's go to the Wikipedia page and let's pick some colors that the user can be. Does anyone want to shout out a color? We need like multiple colors. So
I think one should be orchid.
orchid. I'm sorry, I couldn't hear you. What color?
Thistle.
Okay, thistle. Let's have some variety. I'm gonna do lime. Actually, lime might be harsh on the eyes. Might be harder to see. So I'm gonna do olive drab. Do light salmon. And let's do crimson. So the user is going to pick what color that they want to be. And now we're going to check for errors, okay? So this is something more complicated, but I think you'll always want to do this. So let's say the user does not enter one of the colors that we gave them. What if they enter like A, B, C, D, E, F, G? What happens then? We don't want the program to just die and crash. We want to have some like plan B that happens.
Sorry, maybe said, okay, you can be this color, but the math questions, but there will be consequences.
Yeah, I like your thinking. Yeah, let's do that. So let's first set up a while loop first, right? So while player one color does not equal orchid or player one color does not equal thistle. This manual labor here. We're gonna have to type all this out. Olive drab. Or player one color does not equal white salmon. Or so basically the program is going to check if it is not equal to one of these, then we're going to go through the while loop. So if the user chooses something that is not one of the options, we're going to let them know, error, sorry, please enter a color above. So it's going to tell them, okay, you have to enter something else. And we have to have an input statement again, okay, with a variable attached to it. So we know what to access, right? We can't just have a print statement. If we have just a print statement, you would have no way to use a variable to access it. So I just printed the same thing. For the sake of time, Okay, so now let's to check if the user enters like a word that is in all caps. Let's first we can do player one color equals player one color dot lower. So this is a method, a command that will put all of the letters in lowercase. And now that we have now that the user picks a working color, we're going to change the color of their turtle into the color that they want. So first we have to declare like t equals turtle dot turtle, correct? Because we have not done that yet. So let's call this variable player one equals turtle dot turtle. This initializes this mouse or this turtle, and let's change the color to the color that they chose, which is player one color. And now because we are working with turtles, we're going to change the shape to a turtle. Right, these are all commands that we learned. Player one dot shape is a turtle. I hope you guys are following along because we're going. It's a fun game, right? And we'll be able to go through how we think in the process of creating a game. So now after we have changed the shape, we want to draw the setting, right? We want to draw the little circles that the turtles are going to be at. So we want to pen up, go to some coordinates. The reason we want to pen up is because we don't want the turtle actually drawing where it goes all the time. So if you were working on this on your own, you'd have to test out what coordinates are actually the right coordinates. But I have already done that, and I know that -200, 100 is where we want to go. So it might take some time if you were on your own and testing your own coordinates, but for the sake of time, we have -200, 100. And we did not learn this in the slides, but something that you can do is, remember we have Bob, right? Bob is our second turtle, and we want to create Bob. So let's call him player two, and we can make a clone of player one. Player one dot clone. So it's going to be like an exact copy of player one, but with a different variable name, because they're basically the same turtle, right? But obviously the two turtles cannot be the same color, so let's change the color of player two. Player two dot color is, let's give him a color that was not chosen. It can be, yes, Tim?
Could it be I want dark turquoise.
Dark turquoise. Great. Let me do that. Dark turquoise. So now Bob is the color dark turquoise. And we want to also set up the setting for player two. So player two dot pen up, because we don't want the turtle to be drawing it. Player two dot go to this set of coordinates. So the turtle is going to go, Bob is going to go to -200, 100, -100. And so now we have our two turtles. Let's run our program to see how far we've come. Turtle Training 101. Let's be called. What if I enter something that is not one of these? What if I enter, let's say I want to be pink, but pink's not an option. So I have to enter it again. Let's be this all. Oh, whoops. Is this all not right? This is funky. Looks like we have come across an error here. Looks like even if we enter any of the colors, it's not letting us go through. So let's try to figure out what's going on. So it's something is probably wrong with our like while loop over here, right? Because we're testing if it's not equal to this. We're saying while player one color is not equal to orchid. So if it's not equal to that, if it's not equal to orchid, or if it's not equal to this, I see. Okay, so the thing is, we have or over here, right? Or. But it's not working because player one is not equal to orchid. If I put pink, is player one not equal to orchid? That is true. So it's always going to be true, right? What we have now, if we enter something that is not one of these colors, like ABCD or purple or whatever, our while loop is always going to be true. So we want to change the ors into ands. So the way it fixes it is if all of these are true, then do the while loop. Okay. So let's pause here. I think we're like halfway there, but I'm going to explain our homework and we'll come back to that next week. So final project. Next week is our last and final class. So we're going to dedicate next class to working on our own final project. We're going to showcase what we learned in these 6 weeks. So we want to choose a project or a game that is appropriate for what we've learned, right? It can't be something really, really easy. And it might be frustrating if you choose something really hard. So here are some ideas. You can do a math quizzer, which generates random math questions, and it can be timed. So it can tell the user, oh, it took you like 10.8 seconds. Or you can do a memorizing game or a hangman. Hangman is trickier. And here's a Google Doc link. Here's a Google Doc link for 10 more project ideas. So there's more instructions for these. Obviously, or you can come up with something of your own. The game ideas here are pretty boring, but they are like meaningful, and I know that, right, they're not that hard and they're not that easy, but of course, be creative when you're choosing your own project. I posted a question on Google Classroom for you to put your idea of your final project before next class. So for homework, brainstorm your final project, brainstorm what you want to do. And if you want to get a head start, start working on your project. And I guarantee you that you will need more than the given class time to finish it. So if you have time, feel free to get started. And here are some ideas. You can also use Google to help you, or just come up with something on your own. It's more fun if you come up with it from your own head. And extra practice, obviously, if you want to do past projects like guessing game or rock, paper, scissors, obviously you can do that. And next week is our last class, sadly. So we're going to start by finishing our turtle project. We're halfway there, so we're going to start by finishing the turtle project, and then you will start working on your final project of your own choosing. And if you have any questions or if you need help, we can work on your final project together. So if you need help next week, we'll have class time to troubleshoot. So that is it for today. I'm excited to see your final project ideas in the classroom question chat. So if you have any questions, stick around. If not, thank you for coming. I'll see you next week. Bye. Bye.